Today I'm going to show you how to make 9 of 24. That's a drawing we call it in our class. This is 9 of 24 right here. We're going to start by making sure we account for the 15-degree angle of the main body. That's the best way to start building this part. The way we do that is we build this triangle over here. We're going to start in this is an Autodesk Inventor. So we go into our front view to build the plane. The line that's going to control the plane. That's a separate video where I showed you we're going to make sure that the vertical and the horizontal lines are construction lines. The height of this thing is going to be defined at 3 inches. The angle is going to be defined at 15 degrees. This will be the driving backbone. So if the customer ever changes their mind and wants a different angle, all you do is adjust this one number, and the entire surface is 15 degrees. You can make it 20 degrees, you can make it whatever you want, and it'll literally adjust automatically by starting this way. Now we're going to go ahead and add a plane. We're going to pick our backbone line. We're going to pick our XY plane. We're not going to make an oblique angle. We're going to leave it straight 90 degrees from there. And there's our angle that we're going to draw, our plane at the correct angle that we're going to draw on. Okay? So if the customer, like I said, just to show you, if the customer changes their mind and wants it 20 degrees, you'll notice how now this line is at 20 degrees, but it looks like the plane is there. When we update, boom, the plane updates itself to go to the correct plane, to the correct position. If I change this back to 15 degrees, again, update, boop, pops right back. That's what you want. You want that kind of control. This is the plane we're going to actually draw on. So now we're looking at this plane head on. We have a line that we could use for reference off of my parent plane right here. We have this backbone that we can use here. We have a spot right up there. So I do recommend doing a little project geometry of the dots that represent where my positions are. You'll notice that that back dot went in the wrong spot. I don't want to build anything up there. So that item I delete. This guy's good, but this bottom one, I actually want it right there. So I'm going to project geometry of that up. See how it bounced all the way back there again. So if I do it off the back object, I should get the same result. Let's find out. I can't quite spot that back spot. See this? But I do have that. So if I project geometry of this, it goes straight across. So here's an example where I want to look at my plane that I'm drawing on. So I'm going to pick this thing that says look at. When I click on look at and pick my plane at a 15-degree angle, it'll rotate it so I can look straight at that plane. You want that, you know, because that'll let me look straight head on to this object. So if I minimize this again, I can see my dimensions. This radius over here is 0.875. 0.88 is to the 2 decimal places. That's this upper radius right here. That's common for this side and this side. It says TYP. TYP means typical. I'm going to go ahead and draw my circle. I'm working with a tiny screen here. Hold on. There we go. My circle is going to be up here. There's going to draw one over there and one over there. I drew 3 circles randomly. They're random. They're random in diameter and random in to some degree in location. See, because I can change their diameters. but they are aligned correctly as far as this is aligned to the correct surface, this is to the correct surface, and this is to the correct surface. If I check the dimension from here to here, I should get, I'll accept it, I should get something like 3.16, because when you look at this right here, this is the hypotenuse of a right triangle. This is the hypotenuse of a right triangle. Not the hippopotamus, but the hypotenuse. The 3 inches is the vertical height. The 3 inches is the vertical height. The 3 inches is the vertical height, not the hypotenuse. We know the hypotenuse of a right triangle is what? Greater than the length of either side, because it's the hypotenuse. I know this isn't a math class, but we have to appreciate a little bit of math in here to make sure we know what we're doing. That represents the length of the hypotenuse, 3.10 something or another. You can do the a squared plus b squared. You're welcome to do that. I'm not going to, because I know this is correct. This is mathematically accurate. But you can test yourself. It's a good question to find the answer to. 3 inches is the height, not this height, the height of where these are. And remember, these guys, this circle here, the circles here, the circle here, they're on the vertical plane. They're on the vertical plane. They're on the vertical plane. Where those back there, these back here, are on the hypotenuse portion of the plane. Okay? That's why the number is larger. Please make a note of that. So these are correct in vertical positioning. God only knows where they're at in horizontal positioning. So we have to actually dimension them. That should be 1.25. And this side should also be 1.25. Now I'm really, really lazy. We haven't had that conversation before. We'll make it clear. Your teacher is really lazy. So I don't really want to waste my time and type another number in. So when I go dimension and I pick this vertical position in this circle, and then when I click this, I'm not going to go change this to 1.25. I'm too lazy for that. I'm just going to pick my other dimension. You see how it says D10? Guess what? Now it's got that algebraic formula equation in there. Function of x, 1.25. It's function of x. X is this. You know how they say don't find your x? In this case, we found the x. 1.5, they both update. See that? Isn't that beautiful? That's where that algebra junk, sorry, it's not junk. That's where we use it. Function of x. This drives this dimension. I can type in 2, they both update. Okay? Type in 1.25, they both update. Function of x. If I double click on this, it says D10. D10 means dimension 10, and it shows you. If you let go of your mouse and pause for a minute, D12 is this dimension. It happens to be the 12th dimension I dropped on the drawing. That's what it really means. If you're wondering, why is it 12? Why isn't it 5 or something else? That just happens to be the 12th dimension I dropped on the drawing. So the code for that dimension is D12, and it's attached to D10. You're not going to go hunt down D10. In our case, we know that it's this dimension. That's D10. Every dimension has a tag to it. And yeah, can I go and actually code things if I know what my codes are for each dimension? You bet I can. I had a student of mine literally create a rim, like for a car, a customizable rim. All he did was change one number and literally updated every single dimension. If you document your codes, you can create an automated drawing where you update your entire drawing with one minor change. So there's some neat things you can do with math in this software. So this is your first venture into that. F of x, function of x. Got it? Next, I've got these three circles that I'm also equally lazy about. So I'm going to hold my control key down, hold my control key down, hold my control key down, and pick all three circles. And I'm going to go up here. I got to scooch this over a little bit. So we got your constraints. You have this one called equal. Equal. I'm going to click on it and bang. All of these three circles now are equal. So if I change them, they change together. Okay? I like that. I want that kind of control. Next. On the subject of lazy, making lines tangent to circles can be quite a project. We've all been there, trying to find that exact spot. Where do I put that line so it's dead tangent, right? We've all been there. AutoCAD, every product. It's very difficult to make this tangent, because we know it's tangent. It's tangent there, tangent there. So what I do is I draw a line out in La La Land, as I like to say. Just draw it somewhere out there. Doesn't matter where, just somewhere. Doesn't matter where, just draw it out there. Now, by constraints, you see this tangent looks like a little person with a little hat on. A circle with a line. Click on circle tangent. I'm sorry, click on, I call it circle tangent. It's tangent, sorry. Pick the line, pick one circle, done. Pick the line, pick the other circle, done. Pick this line, that circle, pick this line, part of the line, that circle. Pick this side of the line, that circle, pick this side of the line, that circle. Does it matter what order I did it in? No. But this does matter. Let me show you what does matter. This piece, when I go back here, what does matter is if I pick this line and I pick this side of the circle, oh, it does pick that side. That's good. If I pick this line and pick that side of the circle, it still went to that side. So it's intelligent enough to do that. Anticipated failing sometimes. So I always tell people, be careful which side you pick. You do want to pick the correct side of the circle, because it might actually pick the other side, and you don't want a tangent to the wrong side. So do be careful. This time it worked right, but sometimes it will fail. Your next step is to trim. What's beautiful about this product, this is Inventor 2019, is you just pick trim and you just pick what you want to get rid of. It just automatically selects it. You don't have to sit there and be careful about what you select or worry about which setting you're in, like in other software products. In here, it's mindless. It's beautiful. And there you have your basic shape. When you are done, you just hit escape a few times to get out of everything. And now you see that your object is completely locked together. Now all we got to do is add one dimension, 0.875, which is the radius of that object. And the entire thing is constraining one shot. This particular element is completely controlled by this other sketch. If I change the height to, let's say, 5 inches for fun, I don't know why, because the customer said so. I hit OK. See that? I update. The whole thing updates. Done. If I change this dimension, 1.25 to 5, I don't know why, because the customer wanted it. Done. Everything is controlled. This particular entity right now is controlled by 1, 2, the angle, 3, right there. If I zoom in, my angle, let's say I make that 20, update it. 4 dimensions. Let's say the customer wants to change that to 1. Done. So this entire thing is controlled by 1, 2, 3, 4 dimensions. What was that 0.875? Forgot for a minute. And that's supposed to be 15. Anytime you do this type of change, you do have to hit update. The dimensional changes, they'll, like, this will change everything quickly. But for some reason, when I do stuff with planes, I have to hit update. Fully controlled. That's what you want. It's not good enough to just draw. You want to be able to control what you're drawing for future changes. That pretty much takes care of this piece of it. Let me clean this up a bit. We're done with this back wall. Now what we have to be careful about is how we extrude it. We don't want to mess that up. So now we have this shape. Now we have to pay attention how, I'll stay in red, how, let's see, we've got this shape, right? Now we, oof, that was bad. Let's try that one more time. We have this shape in the back. See that? We have that shape. When we extrude it, we have to think which way we want to extrude it. You cannot extrude forward because your 3-inch parameter is based on the front face. The 3-inch is based on the front face. So you have to extrude backwards. You have to extrude back. So when you go to extrude, your 1/2-inch extrusion of this face is not forward. It is backwards. Not forward. Backwards. You have to extrude away. You have to extrude away. Otherwise you're going to mess up the front. This triangle is drawn in proportion to the front of this object. Okay? Not the back of it. So you have to extrude back. This is very important. That's how you get the correct sides. Once this is done, you see, I left this in so you can visibly see that. That's how it needs to look, guys. That's how it needs to look. If you extrude the wrong way, you're going to lose your position for where these have to be. So you have to do it this way. So you extrude back. Then I'll just hide this. I don't need to see it anymore. When you look at the side view of this, front view, see that? Your plane is on the front face, and you extrude it back. Now comes the fun part. I need to figure out this 2.5-inch mark. This back, this very, very back piece right here, this is this edge right there. So I want to add another plane parallel to this plane, parallel to an existing plane, and attach to that back edge, and attach to that back edge. So I pick the plane, and I pick my edge. But you notice the angle? What does it want to do? 90 degrees to that. I want it to be 0 degrees. So that my new plane literally is on the edge of the back of that part. Because that's where my 2.5-inch mark is. I hit OK. So now that plane, you can see, is dead on partnered with the back of that edge. See that? It's exactly where it's supposed to be. So now I can go 2.5 forward to where the face of these guys are. That's how I can make that happen. So now I create another plane. So yeah, you're right. I had to create this plane to really, I don't need it for any other reason to get them to get my 2.5-inch mark for this plane, which is where I really want to be. Because that's the plane I actually need. That's the plane where I get to draw these in, this object. Because these are on a flat surface, on a vertical surface. These are on a vertical plane, okay? On the vertical plane, those three elements. So I need this back plane to build this front plane. Then I can draw straight on that front plane. Now I can do a project geometry of my curves so I can find my center points for where my circles have to go. These guys. These represent the cylinders, the outer diameter cylinders. Now here I can check myself again. Are these three apart? Oh, isn't it beautiful? See that? Dead on 3 inches. Why? Because I built it right. Okay? This time I didn't give you too many mistakes this time. Unlike my other videos where I try to make mistakes, I said forget about it. I'm just going to build it right this time. See that? These are 3 inches vertically. The hypotenuse dimension, of course, is larger. It's 3.10, blah, blah, blah. You don't care what it is. It's built correctly. Now I just need to equal all of these together because I'm lazy. Okay? Then I can assign one dimension to one of them so that the other two update with it. Okay? And then I extrude. I extrude to face. You can pick to next or to. I like using to. And then I just pick where I want it to go. Come on, you. Alright, fine. Oh, I gotta pick the items. Sorry. I was going too fast. There's the 3 items. And then I want to extrude to that face. There it goes. Isn't that beautiful? Extrude straight to that face. Then I hit OK. So I don't care that they're at different angles, different positions. They just extrude exactly where they're supposed to go. It's a beautiful thing. Isn't that nice? So, the key to that is making sure that you pick extrude to. You can, if you want to, instead of to, you can say to next. It'll be the same outcome. What you don't want to do is try to figure out an actual number, like a distance. I'll extrude at 2.5. Yeah, that's a good idea. Bad idea. If you extrude at 2.5, that's what you're going to get. And you're going to be like, gosh darn it, gee willikers, stronger words to follow. You're going to have to slice off all that stuff. I'm not going to do that. Too lazy for that. I'm going to go back to my extrude and remember what my teacher told me. To next. Or to. If you pick to, you have to pick where it's going to extrude. If you pick to next, it doesn't matter. It just goes to next. For our particular drawing, it doesn't matter which you pick, the result is the same. For other drawings, it might not be the same. Just so you know. You might want to be careful. But for this drawing, it's fine. Our last step is to go ahead and drill some holes. To be specific, some counterbores. We want to drop some counterbores here. So, I got to open this up, sorry. I can't do this right. We're going to go into the hole command, counterbore, pick this face. Can't find the center. Gosh darn it. Did I find the center? No, it didn't. Can't find the center. So I'm going to make a suggestion. There's a little feature called point that you can, oh, I'm not in a sketch, am I? But I can still do it. Let me see if I can get point. Say I have center point of a sphere, center point of looped edges, intersecting, different types of points. Sketch point or midpoint. I could try this one. It's not going to find it. I know that for a fact. If I pick this object and pick point, it's also not going to find a point. So a sphere, to find the center, it won't. This isn't the sphere. Okay? So what you can do, there's a few ways to work with the whole command, is you would have to pick if you pick a spot, see that? What you're missing is how to locate that spot. So you pick the side wall, and it finds the center. Again, hole command, pick where you want the hole, and pick the side of the body, and it finds the center. For a round object, it'll do that automatically. Then all you got to do is identify what kind of hole you want. In this case, we want a counter bore. According to the drawing, it's 3/8 through, 7/8 at a depth of, it says 0.37, so it's an odd number. So we'll change that to 0.37. The larger diameter is 0.875. The through-hole diameter is 0.375. We hit OK. There it is. Now, some people will ask, can I do more than one? Edit feature. Okay, there's the first one. We're going to have to maximize this again. Sorry. Okay, let me drag this over a bit. If I pick this object, that side, pick this object, its side, the answer is yes. There you go. So you got all three in one shot. But again, let me undo real quick. Again, hole command, pick the face, pick the side wall. Put in your dimensions. While you're still in the command, pick the other face, pick its side wall. Still in the same command, pick the face, pick the side wall. That's it. Hit OK. Done. They're all lockstep together. So if the customer turns around and says, you know what? I want it to be 1 inch diameter. Not 5, 1 inch diameter. And I want it to be 1/2 inch deep. I want the hole to be 1/2 inch. Updates them all, one shot. Rinse and repeat. Edit feature. Whoops, customers, never finicky, fickle, whatever words we want to use. Pain in the butt is what we usually say. Now they want to go back. Okay, no problem. 0.37 and what was the 0.375? Yeah, there's a diameter of the hole through. Hit OK. Done. The last thing on this drawing is also the hardest to look at. It's in the back. I've allowed students to personally define how they want to do this back little fin thing that's on the back of this thing. That, so it's also 3 inches, so people get a little confused. They think it should be aligned with this. No, it shouldn't. Doesn't quite look like it's aligned with that. It's really hard to tell where it is, to be honest, if I have to really guess. So if you choose to just build a sketch on this plane, we just start a sketch here, you're welcome to do that, and just go to the line command and just build a vertical shape, okay, and just make sure it stands out. Come on, there we go. 3 inches tall. That's fine, because you're going to find out mathematically. Doesn't quite come up to this 1.23 number that people see here. I'll show you. It actually comes out to some close, but not quite. I'm going to have to drop a spot, a point right here to lock onto. If I try to dimension it from here to here, come on, one more time, dimension it from there to there. It's like a different number. I could type in 1.23. Not sure it's going to take. So you move that off the part. It really isn't at 1.23. If this is truly locked into that position, you can't tell. That's the problem. You can't honestly tell where it's locked in. But you do tell the 3 inches locked in. So the question is, well, maybe the 3 inches isn't dead on the bottom. Maybe it's somewhere else. I don't care which way you build it. I'm flexible. Some people want it 1.23 from this top position. Some people understand that it's not exactly that. Like if I drew my triangle out here, for example, and made it the correct height of 3, and presumed that this dimension is really the length of whatever this shape is over here, whatever this is, 1.23. Okay, if I did that, I can take this shape and attach it to this shape by using a collinear constraint. It might not move. Let me try it. Yeah, you see it won't move. It's not that angle. See that? It doesn't work. This shape, so more likely than not the 1.23 is not there. It's probably from here. So now if I try to attach it to this, not that, attach this, hold my control key down to this, and use collinear, it will attach. It'll move on the surface. It'll slide up and down the surface. Now if I assign that dimension, before I can do it though, I have to put in a point at this intersection. This point has to be attached there. Now if I go ahead and dimension it from here to that point, put in 1.23, the point moved off again. Sorry, let me drag this over. And this slides up to wherever the heck it goes. We don't know if it's locked in at the bottom. If we have conflicting information. We see this dimension of 1.23 and this dimension of 3. Thank you. Thanks. So if we try to satisfy the customer's request with this dimension here and this here, it isn't locked in at the bottom. It's off. So we have to tell the customer that. We know that it can't be 1.23 by 3 as far as the triangle because the angle is different. It doesn't work. So I have to do it this way. And we have to tell the customer, hey, customer, you know it's not locked in at the bottom. Do you want it locked in at the bottom? If you do, then the 1.23 number doesn't make any sense. We have to tell them that. Your last step will to go ahead and do the extrude of this back fin mid-plane, a distance of 0.31. Mid-plane though, mid-plane, and hit OK. And there you go, that's your rib. Stuck on the back of it. My guess is it's wrong, there's something wrong. Because why would it be there? It's not flush, it makes no sense. But those are the dimensions the customer gave us, so we have to go back to the customer and say, here's a drawing, based on your specifications, do you really want this? And make them verify it. And that ends how this would be built. That's how you would build this.